Hi students, Professor Nugent here. Let's talk about autoregressions. A natural starting point for a forecasting model is to use past values of y, so these are our lags, yt minus 1, the lag yt minus 2, etc., to forecast the value of yt. An autoregression is a regression model in which the value of yt is regressed against its own lag values. So yt minus 1, yt minus 2. So the current value is regressed against the past values. The number of lags, the number of past values used as regressors is called the order of the regression. So that's the number of lags is the order of the regression, okay? In a first order autoregression, yt is regressed just against the first lag. First order, we have the first lag, that's yt minus 1. In a p order autoregression, yt is regressed against yt minus 1 and yt minus 2 all the way through yt minus p. Alright, that's the pth order autoregression. P may be 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. Let's focus first on the first order autoregressive model. The population AR1 model is given by this equation next to the big rainbow star, where yt is equal to beta naught plus beta 1 times yt minus 1 plus ut. Our coefficients beta naught here and beta 1, they do not have causal interpretations. If beta 1 is equal to 0, then yt is not a useful tool for forecasting yt. In other words, yt does not enter the equation. The AR1 model can be estimated by an OLS regression of yt against yt minus 1. So mechanically, how would you run this regression? You would need to generate a new variable that is the lagged values. And in this data tutorial, we're going to talk about how to do that. Testing the null hypothesis that beta 1 is equal to 0 against the alternative provides a test of the hypothesis that yt is not useful for forecasting yt, and our usual test statistics will be used to test this hypothesis. The AR1 model is estimated in this example for the growth rate of GDP using data from 1962 quarter 1 through 2017 quarter 3. The estimated GDP growth rate is given by this equation: 1.95 times 0.341 times the growth rate of GDP, t minus 1. The adjusted R squared is 0.11. The standard error of the constant is 0.322. The standard error of the coefficient on the lagged value is 0.341. Here, GDP-GR, this is the percentage growth of GDP at an annual rate using log approximation. So let's ask, is the lagged growth rate of GDP a useful predictor of the current growth rate of GDP? We're going to test the null hypothesis that beta 1 equals 0. The test statistic is the value of the coefficient minus 0 over the standard error, which is 0.31 divided by 0.073. That's equal to 4.67, which is greater than 1.96, the critical value at a level of significance of 5% in absolute value. And so we reject this null hypothesis. We reject that. So we conclude that yes, the lagged growth rate of GDP is a useful useful predictor of the current growth rate, but the R squared, that's still pretty low. So we're not predicting much of the growth rate. We're not explaining a lot of the variation in the growth rate. Let's look at a prediction the AR1 estimated data using 1962 quarter 1 through 2017 quarter 3, and this was the model that we estimated. The growth rate 2017 quarter 3 is 3.11%, units are percent at an annual rate. The forecast given by the model here next to the big rainbow star is one of 2017 quarter 4, the forecast quarter 4 given the growth rate in quarter 3 is 1.95 plus 0.341 times 3.11, which gives us 3%. So here in this example, we forecast that fourth quarter of 2017 gross domestic product will increase by 3% at an annualized rate based on a 3.11% growth rate in 2017 of quarter 3. Now let's take a look at the ARP model. This is the general autoregressive model using multiple lags for forecasting. The pth order autoregressive model is this equation next to the big rainbow star: yt equals beta naught plus beta 1 times yt minus 1 plus beta 2 times yt minus 2 plus all the way through beta p times yt minus p plus ut. The ARP model uses p lags of y as regressors. And in a video or two, we're going to discuss how to choose how many lags to include in the model. The AR1 model is a special case where p equals 1. And again, these coefficients do not have a causal interpretation. To test the hypothesis that yt minus 2 through yt minus p do not further help the forecast of t beyond yt minus 1, you would use a typical f-test, where you would set the coefficients equal to 0 in a null hypothesis and use the test command in stata and include those variables. Use that f-test, test the null hypothesis that those coefficients are equal to 0. If the p-value is less than 0.05, you can reject that null hypothesis in favor of the alternative that those lags further help the forecast. We'll use the t or f-test to determine the lag order of p. Better yet, we're going to use the information criterion. This is the best way to choose p, and we're going to talk about that in a video or two. Here is an example of an AR2 model for the growth rate of GDP. We have the predicted growth rate of GDP on the left-hand side. On the right-hand side, we have 1.6 plus 0.28 times growth rate times GDP growth rate t minus 1 plus 0.18 GDP growth rate t minus 2. To test the hypothesis that yt minus 2 do not further help forecast yt beyond yt minus 1, you just use a t-test, right? That this additional lag, we're going to test that this additional lag, this thing right here, does not further help forecast GDP growth rate beyond the first lag. To test that, you just use your typical t-test. You're testing the null hypothesis that beta 2 is equal to 0. And how do you test that hypothesis? It's a hypothesis test of one coefficient, and you do that with just a t-test. The t-test is the estimated coefficient 0.18 minus 0 divided by the standard error, which is 0.08. You get a test statistic of 2.3. You compare that to the critical value given by the standard normal cumulative distribution. That z-value is 1.96. Your test statistic is greater than the critical value, so you can reject the null hypothesis. You reject that thing. You reject that thing in favor of the alternative, which tells us that this second lag, the second one right here, the second one does indeed further help the forecast of yt beyond yt minus 1. Note that the adjusted r squared increases slightly relative to the AR1, and the second lag is still statistically significant. Still, most of the variation in next quarter's GDP growth remains unforecasted because the adjusted r squared is still low, so there's a lot of variation that we're not explaining, and we would like to do better. So how can we do better? We're going to talk about how we can do better in the next video.